In this video, we will be exploring the concept of transformations, which are primarily vectors, more specifically. And we'll be going into more detail about what a vector is in this little story I have prepared. So we have points A, B, C, D, E, and F on the map of the United States, and let's just say Bob is starting his destination at A, and he's taking a trip to each of these points. So let's say he goes from San Diego, California, to Olympia, Washington, to Cheyenne, Wyoming, to St. Paul, Minnesota, to Albany, New York, and to Tallahassee, Florida. Now I know the points aren't exactly on the spot of the cities I just mentioned, but for video purposes, we are just using coordinates that are a lot simpler so we don't get a decimal. So now let's just start with Bob's first excursion, which would be from point A to point B, or San Diego to Olympia, Washington. And let's just select. So first off, we are basically trying to figure out the vector at which Bob travels at, from point A to point B to point C, the vector he travels at from C to D, the vector from D to E, and the vector from E to F. And once we have all these, you will see it will start to form a shape, and we will go into adding vectors once we get to trying to figure out the vector from his point F to A. So basically when he returns home. And first, let's just start with the first excursion, which is from point A to point B. So before we get into the vector notation, and we should first talk about what a vector is. And a vector is basically something that has direction and magnitude. By direction, it's obviously in which direction the arrow is pointing, and by magnitude, it's basically like how big the arrow is, or like how much position changes, or how great of a value the position changes at. And when looking at a vector, there are two main points. Its initial point, so which is like where you start, where your first destination is, and your terminal point, which is where your end point is. So for this case, the initial point is basically San Diego, California, and the terminal point is Olympia, Washington. Now, there are also two components to a vector, which are its vertical component and horizontal component. And the horizontal component would be a change in position on the x-axis, as you can see, and a vertical component is the change in position on the y-axis. Now, when looking at vector notation, you can see that it looks similar to a fraction, one number on top of the other, and the top number is the horizontal component and the bottom number is the vertical component. Now, there are two ways to write vector notation, but I think this is the one that's more commonly used. And so as you can see, when looking at these 2 points and the vector notation, if you basically add these points together, you would get -2 or 6. Or if you just add one of these vectors to the other, you would receive the others. It would be equivalent to one of the points. So, for example, let's add this to point A. -2 plus -6 would equal -8, and 6 plus -2 equals +4. And over here, we can see the actual movement of the point. So it would be, so the horizontal component would be -2. So we go back 2, and it would be the vertical component would be +6. So 2, 4, 6, and you would end up here. And that's pretty much actually what a vector is. So let's go on to the next the next destination. So from B to C, our vector would be 6 to negative 2. And if we add that to B, 6 plus negative 8 is negative 2, and negative 2 plus 4 is 2. So, and over here on the graph, you can see we go 2, 4, 6, and then we go down negative 2, or down 2. And that's how, that's the vector from point B to point C. And just to make it clear, the initial point would be Olympia, Washington, and the terminal point would be Cheyenne, Wyoming. Because although this was our terminal point previously in this one, since this is now the new starting point, this becomes the initial point, and this is the new end point, so that's the terminal point. So we go from C to D. The vector would be 5 to 2, so it would be over 5 and up to, or if we add it to C, 5 plus negative 2 is positive 3, and 2 plus positive 2 is positive 4. So we would go 2, 4, 5, and then we would go up to, which is right there. And the terminal point is D, and the initial point would be C. Now let's go to the next one. So this is from St. Paul to Albany, New York. And this vector would be 8 to negative 2. And adding that to point D's coordinates, that would be 8 plus 3 is positive 11, and negative 2 plus 4 would just be positive 2. So as you can see, if we go here, so we go 2, 4, 6, 8, and then we go down 2, you would end up right there. From here to here. And this vector is from point E to point F, negative 3 to negative 7. So we would go back 3, or yeah, so we go 2, and then we 3, because you'll end up with 8, and then we go down 7, so that'd be 2, 4, 6, 7, and you would end up at point F. And if we add that to point E's coordinates, that would be 11 plus negative 3 equals positive 8, and negative 7 plus 2 equals negative 5. Okay, and like I mentioned before, as you can see, these vectors are now starting to form a shape. And with vectors, now we're going to be going into adding vectors, because if we add all these vectors, it would give us this missing vector without us even having to create one on GeoGebra. So if we were to add all these, you would basically add all the horizontal components plus all the vertical components, and the sums of both would be this vector. So 8 plus negative 3 is positive 5. Positive 5 plus negative 2 is positive 3. Positive 3 plus 6 is positive 9. And positive 9 plus 5 is 14. So just remember that our horizontal sum, component sum, is 14. And for the vertical component, it would be negative 2 plus negative 7 is negative 9. Negative 9 plus 6 is negative 3. Negative 3 plus negative 2 is is negative 5. And negative 5 plus 2 is negative 3. So, this vector should then be 14 to negative 3 based on our addition. And to check if it's right, we can do what we've been doing before. And yep, see, the vector here is negative 14 to 3. And if we were to add that to this point, we would get the coordinates of point A. So negative 14 plus 8 would equal negative 6, and 3 plus negative 5 would equal negative 2. And as you can see, it forms a general shape. So, yep, that's it. That's all there is to vectors.